Hey, what's up, guys? We're gonna be studying for physics test. Um, all right, chill. Okay, let's start. So I'm just gonna start doing questions, and should be it, yeah. As far as A and B are identical horizontal tracks, we'll see if current A changes from 2 to 5, equal to 1 to 3. The ratio of the average acceleration. This is pretty simple. So A is gonna be obviously 1, and then B is gonna be 2. So 1 to 2 seems like the very obvious answer. Okay, find time equals 0, as in one dimension on horizontal surface. The instantaneous acceleration. All right. Instantaneous acceleration. Find the change of velocity between these times. I think that would be the best approximation. Chill. Okay. A car on a straight road is at rest at position x equals 0 from time equals 0, time equals 1. At t equals 5, the car is at position x equals 40 meters. And at t equals 10, the car's at position x equals 80 meters. The average velocity of the car between t equals 0. No, I think they're equal, so I think the answer we would pick would be no, because the car travels the same distance for the same amount of time in both intervals. This feels kind of trivially true, but okay. A ball is launched vertically down with the initial speed velocity 1. Instantaneous speed. Okay, so obviously it's going to be uh, acceleration equals change in velocity over change in time. Acceleration times change in time equals plus velocity initial. So v1 plus gt1. We're all thrown vertically up in the air from a height of 2 meters with initial velocity of 15, which could be a possible height of the ball at some point along its trajectory. All right, cool. So position final, minus equals velocity initial plus change in time plus 1/2. I'm just gonna say -5. So -5t squared plus 15t equals x final. My super. So these are valid positions. So these are all like valid positions. Okay. We need to find the valid velocities, right? So the acceleration is obviously going to be -10 equals final -10 change in t equals -10t plus 15 equals final velocity. All right, so these are all valid velocities. What we can do here is we can we can find change in t in terms of velocity final. So velocity final minus 15 over negative 10. So then what we can do is we can do basically substitute in. So we can do 15 multiplied by velocity final minus 15 over negative 10 minus 5 multiplied by velocity final minus 15 over negative 10. I don't think this is the most efficient approach, but it should get as a answer. So then we'll just do negative 3 over 2 velocity final minus 15 minus 5 velocity final minus 15 squared over 100 minus 2. Okay, and then simplify this further. This becomes negative velocity final minus 15 squared over 20. Oh, let me just substitute the whole negative one out. So it becomes 3 over 2 and velocity final minus 15 minus 5 velocity final minus 15, or plus 5 velocity final minus 15 divided by 100 squared minus plus 2. So now we just plug in numbers of velocities. So let's plug in. This is very ugly. This is really ugly. This is like a really ugly problem. It's the way I'm doing it. Wait, there's got to be a more efficient way to do this. Okay, let's just look for a more efficient way. It's just really the way we have to be doing this. Okay, we'll just come back to this one. Okay, wait. So, before it reaches the ground, wait, this one is pretty easily checkable, right? We plug in x final equals 0. Yeah, we plug in x final equals 0, so that just becomes 15t minus 5t squared minus 2. So that's pretty easy. That's, I believe, solvable. So let's try to solve it. So 15t minus 5t minus 2. We get 2 decimal values for t. And then we're supposed to plug those values in, but all right, let's go back. Let's go back to this one. At t equals 2, it's at a constant speed. I think t equals 1 is accelerating. The car moves across a straight line. The car's velocity is a function of time as shown in the graph. T equals 2, the car's motion changes. Shown the graph was the ratio of the magnitude car's displacement from t equals 0. T equals 0. Okay, so this is pretty simple. We'll just run the area here. That would be 2 plus so 2 multiplied by 0.5 divided by 2, 2 multiplied by 0.5, 1 half. Okay, so 1 half plus 2, so 3, that's 5 over 2. The area here would be 1, the area here would be 2 6 over 2 is 3, 5. I think we've done something wrong here. No, I think it's 1 half plus 2, 4 over 2, 5 over 2. 5 over 2. Three plus 2, 5. 5 to 10. Oh my god, I'm so stupid. It's 1 to 2. so trivially true. Okay, should have realized. Okay. Yeah. The toy car moves across a level track. The coins are placed um, beside the car's position at the track every second. Coins are placed in diagram. Acceleration is not constant. Airplane travels at constant VA relative to the air. Travels from city X to city Y. I think TR should be less than TM. By what ratio? Right, that's the question. So I think the ratio that's important here. I think the ratio that's important here is this ratio, right? So I think you take the velocity of the plane. Okay, so we're trying to TR has to be decreased. So it'd be okay. So on a trivial basis, let's say the plane was moving at. But if we're moving 0 meters here, it would be moving at negative um, a negative amount here. So I think it's VA minus VW over VA. I think it's C. Because, for example, if the wind isn't moving, move at the same speed. Yeah, C seems right to me. let's begin. Okay, which means that it was initially going at VO, right? So this would be VO sine theta, VO cosine theta. Negative GT, acceleration times time equals velocity final minus velocity initial, plus VO sine theta equals VO final theta, V final, right? That seems pretty logical. But V final would be equal to 0. Right, so then it would be VO sine theta equals GT. So T is equal to VO sine theta over G. So, okay, so position of the wall is going to be Vx by T wall VO cosine theta multiplied by the new time identity, which is VO sine theta over G. Yeah, so this seems like that would be the answer. Maybe we made a simple mistake, but the reason I have this divided by 2 is I just don't know why it would be. Balls kicked at a 30-degree angle above level ground with initial speed 12 meters per second, initially immediately before the ball returns to the ground. Wait, launcher can launch a projectile with initial speed velocity at the edge of a tabletop at any angle between 0 and 90. It increases. While horizontal thing, no matter what, would be cosine theta. And as cosine theta increases, it starts off increasing really sharply and then slows down. Okay, wait. So it's really just a question about cosine of theta. so d cosine is going to be negative sine theta.